You should always involve the tenant in this context and also communicate the positive measures that have been implemented, where you say, look, we have saved costs, we have implemented the measures, we are moving in the right direction. I think this is a very important point, also in tenant communication.
Das ist gar nicht so einfach genau zu erkennen, weil erstmal
It is not so easy to recognize exactly. First of all, I want it to be warm. I want the tenants to be warm so that no one complains. This means heat is supplied to the building, and as long as no one complains, the system is running well. This is how it is operated today. Efficiency must then be considered, that is, how much heat is produced with the gas used. This is called the efficiency factor. So if I put in 1 kWh of gas, at least 95% heat should come out.
0,95, also 95% Wärme.
That is what is measured. Then I have a good efficiency factor. The system then runs efficiently at first. The second point is that not only is the system efficient, but heat is also supplied when I need it. That is when the building cools down and the tenant needs heat. This is the second consideration and the focus we have as a company, as KUGU. We ask, when does the tenant actually have a corresponding heat demand? When are they at home? When is the heat requested? When is maybe also the outside temperature taken into account? This is a second factor that we can identify. Efficiency means how well is the system adjusted and when do I actually need the energy?
Gut ist die Anlage eingestellt und auf der anderen Seite, wann brauche ich denn Energie überhaupt? Es hilft schon mal, heute auch schon im Gebäudeenergiegesetz verpflichtend diesen Heizungscheck. Ich stelle Heizungsanlagen auf die...
It already helps that today, also required by the Building Energy Act, there is the heating check. I parameterize the heating system, set it correctly to the current demand. There is something like a heating curve. When it is cold outside, more heat should be delivered. When it is warm outside, less heat. This is a curve that can be set on the heating system, or operating times. Night setback is a typical operating time, meaning it gets warm at 7 a.m., then until 10 p.m., and the temperature level is lowered at night. These are measures that can be implemented quite quickly, with your heating installer, your maintenance company, or independently. There is a savings potential of up to 10%, which can be realized. A relatively quick and simple measure to get a few percent savings. What we do is go significantly one step further. We as KUGU go and say, what is the building like? What is the building physics? When is heat lost? When is heat gained? With this information, we can control a system much more dynamically. We control it only when heat is really needed. Example, sunshine. It is cold outside, but the sun shines on the building. A heating system will continue to heat because it says it is cold outside. We then adjust the heating system and take temperatures in phases when, for example, the sun is shining on it, or where certain wind conditions, humidity exist. All of this influences tenant comfort. We accordingly adjust the system. We implement a dynamic, predictive control. The effect we achieve there, we guarantee 12%. That means we guarantee a saving of 12% on average. Overall, our systems, we are currently at 23%. That means we achieve 23% savings on average over all our systems. This means for poorly adjusted systems up to 30%, 35% is even possible, and for very well-adjusted systems or systems where there is not much to optimize, we are then at about 14, 15, 16%. The range is quite large. Optimization measures can range from this to that and be implemented.
Das heißt, so Optimierungsmaßnahmen können von bis entsprechend liegen und auch entsprechend umgesetzt werden. Normale Heizanlagen, wie sie heute sind, die liefern ein Angebot. Das bedeutet, draußen ist es kalt,
Normal heating systems, as they are today, provide an offer. This means it is cold outside and I supply the building with the appropriate heat. I offer the tenant an offer that he can accept or not. This means, however, that in many cases an offer is made that is not used. We waste energy at certain times of day, in certain constellations. Demand-controlled control means that we want to achieve a comfort temperature in a room. This can be influenced by external factors such as solar radiation, wind, humidity, etc. And of course, by building physics. A building facing south with all its windows naturally has more energy gain from the sun than a building facing north and less solar gain. We take these constellations into account in our model to always provide the appropriate demand for the next 24 hours to reach the comfort temperature of, for example, 21 degrees.
Bedarf bereitzustellen, den Komforttemperatur von zum Beispiel 21 Grad zu erreichen. Wenn wir uns anschauen, das Wetter hat natürlich einen sehr großen Einfluss, weil das Wetter natürlich beeinflusst, wie viel Wärme brauchen wir denn.
Weather, of course, has a very big influence. Weather influences how much heat we need. This includes temperature, wind speed, humidity, solar radiation. Our model is based on about 25 weather parameters. The current optimization we make is, we want to save maximum energy. Maximum CO2 savings. The problem we solve is an optimization problem focused on energy saving. The energy world will continue to evolve, and it will become more important to consider flexibility as well. The market price could be cheaper at noon because more PV electricity is available than in the evening or at night. The market price plays a role when I say I do not only want to save maximum CO2, but I want to save maximum CO2 at minimal costs. For example, we could use a heating system during the day where we supply energy or produce energy, even though it is not yet needed. But energy or better heat is slow to change. This means I can fill a buffer storage. I can already supply the building with heat before it is actually needed and take advantage of the times when it is cheap. Market prices play a role here. User behavior also. On weekends, I have a different user profile than during the week. In school, I have a different profile than in a residential building. We take these factors into account in the control and can solve optimization problems accordingly.
Faktoren berücksichtigen wir in der Steuerung und können da entsprechend Optimierungsprobleme lösen. Die direkten Vorteile sind natürlich relativ klar. Wir sparen Energie.
The direct advantages are of course quite clear. We save energy. As soon as we are installed, we save, let's say, 20% energy from week one. This is the impact that goes directly to the landlord and directly to the tenant. The indirect effect is that we collect data over the long term to show the customer, especially the owner, possibilities how they can decarbonize, which measures they can derive to turn a gas system into a heat pump system.
Kann, eben aus einer Gasanlage eine Wärmepumpeanlage zu machen. Für Wohnungsunternehmen liefern wir den einfachsten.
For housing companies, we provide the simplest and fastest component to make buildings more energy efficient and to collect data to derive the right measures in the future to decarbonize buildings.
Wirklich die Gebäude zu dekarbonisieren.
The box we install is a universal box. It works for all manufacturers. For all building and system types, whether Wiesmann, Buderus, Vaillant, Wolf and so on, all system types. Or also gas systems, district heating, oil heating, heat pumps. We have no restrictions here. Besides the control technology, besides the system technology we connect, we also have all the metering technology. Electricity meters, gas meters, district heating meters, heat meters, temperature sensors. All this goes into one infrastructure, which we provide. If the customer already has a system, for example from a manufacturer, for example from Wiesmann or Vaillant, then we can access it via the cloud system and do not have to install our own box. That saves costs again and is less effort for installation. This can be connected very quickly to an existing building that might already be digital.
Bestand, der vielleicht schon digital ist, ausgestattet werden.
An important point since team capacities are often limited. For us, it is important that the customer has as little effort as possible. We need access to the buildings once, when we equip them, but we also need some basic information. Some customers can simply provide that to us, but we also offer inspections. We do initial inspections and collect the information on site ourselves, so for the customer, it is maximally flexible to decide how much they want to do themselves and how much KUGU should do.
Der KUGU-Optimierungsservice hat im Endeffekt zwei Bausteine. Das ist
The KUGU optimization service basically has two components. The first is the infrastructure needed in the building. That is the gateway that is installed. This is a one-time expense that many companies make as an investment. The second component is the optimization service, which optimizes the system daily and which is more like software running in the background. This service is a monthly fee, an annual fee, and these costs are reviewed according to the Heating Cost Ordinance and are allocatable.
auch begutachtet nach der Heizkostenverordnung, umlegbar auf die Mieter. Das ist sehr einfach möglich, weil wir reden von einer Ausstattung, die dauert wenig.
This is very easy to do. We are talking about equipment that takes a few hours. We can equip 5 buildings per day with one team. If we get larger portfolios, we can equip thousands of buildings in a few weeks or months. This is maximally scalable in terms of pure on-site implementation. But also, system replacement is technically very easy. The cable is unplugged from the old system, the new system is installed, and it is plugged back in. It is future-proof. You are not investing in something that has to be rebuilt with every system replacement. The technology as a core component in the building remains the same.
Die als Kernkomponente im Gebäude, die wird gleich bleiben. Im Endeffekt, die Zusammenarbeit basiert so in 3 Schritten. Der erste Schritt ist die Ausstattung. Das heißt, wir müssen im ersten
The collaboration happens in 3 steps. The first step is the equipment. We have to connect the system, that is, bring the system online. Once that is done, the second step happens. That is modeling. In 4 days, an automatic process creates the digital twin and stores a physical formula for the building. The third step is an optimization service. This usually happens 1 week after installation. The customer will be able to see results very quickly. In our portal, he can log in and see how much he saved yesterday, how much in the last week, in the last month. He can evaluate anytime.
Wie viel habe ich eingespart in der letzten Woche, im letzten Monat? Also da kann er jederzeit Sachen auswerten.
Implementing our product means no change for the tenants at first. Comfort will be maintained. Tenants will have no restrictions in how they use their building today. But decarbonization is, of course, a bigger topic. It is about individual room control, about gas systems, heat pumps, that means different temperatures, different user behavior that is sometimes necessary. You should always take the tenant along in this context and also the positive measures that have been implemented, where you say, look, we have saved costs. We have implemented measures. We are moving in the right direction. I think this is a very important value, also in this tenant communication. And many of our customers do this proactively, where they repeatedly share their examples, where they have implemented measures that are also positive and communicate that simply.